This video we'll be discussing about Mathematics Paper 4 Mechanics 2023 May June Variant is 41 and the subject code is 9709. Question number 1. Two particles P and Q are of mass m kg and 0.3 kg respectively are at rest. Rest means its initial speed is 0. On a smooth horizontal plane, P is projected at a speed of 5 meter per second directly towards Q. So particle P moves with 5 meter per second towards Q. After P and Q collide, P moves with a speed of 2 meter per second in the same direction as it was originally moving. Find in terms of m the speed of Q after collision. So we need to find the speed of Q in terms of m. So we know that by momentum, that is momentum before collision is equal to momentum after collision. Momentum is equal to mass into velocity. So momentum of P plus momentum of Q is equal to momentum of P, and the velocity is positive since it is moving in the same direction, plus momentum of Q, and we need to find this value of V. So after solving, we find the value of V, that is 10 m in terms of m. After this collision, Q moves directly towards a third particle R of mass 0.6 kg, which is at rest. So the particle R is at rest on the plane. Q is brought to rest in the collision with R. So after collision, Q is at rest. R then begins to move with a speed of 1.5 meter per second. So then R starts to move with a speed of 1.5 meter per second, and initially Q is moving towards R, and after collision, since Q becomes rest, so R would obviously move forward, that is in this direction. So momentum before collision is equal to momentum after collision, and we get the value of m, that is 0.3 kg. That is the value of m. So a particle P of mass 0.4 kg is projected vertically upwards. So P is moving vertically upwards from the horizontal ground with a speed of 10 meter per second. So its initial speed, that is u, is equal to 10 meter per second. Find the greatest height above the ground reached by P. So we need to find the greatest height, and we know that at greatest height the velocity is equal to 0. So we know that the final velocity, that is 0, initial velocity, that is 10 meter per second, and as the particle is moving upwards, so the acceleration is negative, and if the particle is moving downwards, then acceleration is equal to positive, and for mechanics the acceleration is 10. So the distance comes to be 5 meter. When P reaches the ground again, it bounces vertically upwards. So when P reaches the ground again, that means at this point, it again bounces vertically upwards. At the first instant, when it hits the ground, it loses 7.2 joules of energy. So at the first instant when it hits this ground, it loses 7.2 joules of energy. Find the time between the first and the second instant at which P hits the ground. So this is the first instant, and this is the second instant at which P hits the ground, and we need to find the time difference, that is the value of t between these two instants. So to calculate the value of time, we need to first find, or we can actually use the equation, that is v is equal to u plus at, and we have to just find the time for this interval, that is from the first instant to this point, and we know that at this maximum height the speed is 0, and so we can use the equation v is equal to u plus at. That means at this maximum height the v is 0 and u plus at, we know the value of a, and we need to find the value of t, and after finding this value of t, we know that this value is same as this value of t. Since this is a symmetrical movement, so same value of t, so we can actually then multiply the value of t with 2 to find the total time. So to find this first value of t, that is this value of t, we need to find this value of u. So what is the value of this u? That means we need to find the speed at this point, that is u. So we know the gravitational potential energy, that is gravitational potential energy is equal to mass into gravitational field strength into height, and we know the value of mass, that is 0.4, gravitational field strength, that is 10, and height, that is 5. So after substituting these values, we find the gravitational potential energy. So we know the gravitational potential energy at this point, and to find the speed at this point, we can actually equate the equation, that is gravitational potential energy is equal to kinetic energy at the first instant, that is at this place, the kinetic energy, that is Ek, plus the energy lost, that is 7.2 joules. So what is the kinetic energy at this point? Kinetic energy is equal to half mv square. So we can use this equation to find the value of u, that is 8 meter per second. That means the speed at this point, that is the value of u, comes to be 8 meter per second. As we know the value of u, then we can easily use the equation v is equal to u plus at to find the value of time, that is the time at this instant. And what is the total time from the first instant to the second instant? So we need to find this value of t into by 2. So we can multiply the time by 2 to find the total time between the first and the second instant at which p hits the ground. So from this instant to this instant, the total time that comes to be 1.6 seconds. Question number 3. A particle moves in a straight line starting from rest. At rest, initial speed is 0. The displacement s of the particle from a fixed point O on the line at time t seconds after is given by this expression, that is the displacement. Find the value of s when the particle again comes to rest. So at rest we know that velocity is equal to 0. So to find the value of s, first of all we need to find an expression for velocity, then equate it to 0 to find the value of time. As we know the value of time, then we can easily substitute this in the displacement equation to find the displacement. So after substituting the value of t in the equation, we get the displacement as 15 by 16 meter per second. In question number 4, the velocity of the particle t seconds after leaving a fixed point O is v meter per second. The diagram shows a velocity time graph which models the motion of the particle. The graph consists of 5 straight line segments. So 1, 2, 3, 4, 5. 5 straight line segments. The particle accelerates to a speed of 0.9 meter per second. This is 0.9 meter per second in a period of 3 seconds. So 3 seconds, and then travels at a constant speed for 6 seconds. That means in total 9 seconds. And then comes instantaneously to rest for 1 second later, or instantaneously rest 1 second later. The particle then moves back and returns to O at time t seconds. That means it starts from O, then it comes to a point, and again it returns to O. That means this distance covered is same as this distance, and the total displacement is 0. Find the distance covered by the particle in the first 10 seconds of motion. So for the first 10 seconds, this is the area of a trapezium, that is half into sum of two parallel sides, that is 10, and 6 into height, that is 0.9. So the distance comes to be 7.2 meter. Given that t is equal to 12 seconds, find the minimum velocity of the particle. So at this point, we know the value of t, that is 12 seconds. We need to find this minimum velocity, that is this value of v. So to calculate this value of v, we actually know the distance across this area is same as the distance across this area, or the displacement across this area is same as the displacement across this area. So what is the displacement? The displacement or the distance is in this area is 7.2. So the displacement or the distance in this area is also 7.2. That means the total displacement is 0, but for this area the displacement is 7.2, and we know the value of time. We need to find the value of v. So displacement is equal to, that is the area under the velocity time graph is the displacement, that is 7.2. So area under the velocity time graph is equal to displacement, and the area is half into base into height, where the base is 12 minus 10 and the height is v. So this is the value of displacement, then half into base into height. After calculating, we get the value of v as negative 7.2. This implies that the velocity is negative. See, given that instead the greatest speed of the particle is 3 meter per second. So it mentions about the greatest speed and not the velocity, since it is a velocity time graph, and so the velocity can be positive 3 or negative 3 meter per second. And as we know the value of positive velocity, that is earlier given in the question, so it must be negative velocity, that is negative 3 meter per second, since it is velocity, and it is the greatest velocity in the negative axis. So 3 meter per second, find the value of t, hence find the average speed. So first of all we need to find the value of t, that is this value of t. We need to find this value of t, and we know that the displacement in this area is 7.2. So we know the displacement, we know the speed, and we know the speed. So we can actually use the area of the triangle again, that is the area under the velocity time graph, that is the displacement. So we can use this to calculate the value of time, that is half into base, that is t minus 10, into height, and the height is the velocity, and since it is at the negative axis, so it is minus 3. So minus 3, and since the positive displacement, that is 7.2, cancels with the negative displacement, and so the positive displacement is from O to a certain point, that is, suppose this point is M. So the positive displacement in this direction, and the negative displacement is against at O. That means the value of negative displacement is negative. So after calculating, we get the value of t as 14.8 seconds. So we know the value of t. Now we need to find the average speed. Again, it mentions about the speed and not the velocity. So we need to find the average speed of the particle for the whole motion. So to find the average speed, we need to first find the total time and then the total distance. It is distance and not the displacement since it is speed. So we know that from O to a certain point, the distance is 7.2 and again returns to O, so the distance is 7.2. So in total, the distance comes to be 7.2 plus 7.2. That is, the total displacement is this value, that is 7.2 plus 7.2 or 7.2 into 2, and the total time taken would be the total value of t, that is 14.8. That is, this total distance, this distance and this distance plus total value of t, since t is the total time, that is this total time. After calculating, we get the average speed as 36 by 37 meter per second. 5. For coplanar forces act at a point, the magnitude of the forces is F Newton, 40 Newton, 10 Newton, and 50 Newton. The relation of the forces are shown in the diagram, given that the forces are in equilibrium. So the forces are in equilibrium, we need to find the value of F and the value of theta. That is this value of F and this value of theta. So first of all, we need to find the horizontal and the vertical component of the forces, and the horizontal component is cos theta and the vertical component is sin theta. So we have found the horizontal and the vertical component, and since the forces are in equilibrium, so left is equal to right, left is equal to right, and top is equal to bottom. After equating these forces, we get two expressions, that is expression 1 and expression 2, and after solving it, that is sin theta by cos theta is equal to tan theta. So we can solve this in this way and find the value of theta. As we know the value of theta, so we can substitute it in any of this equation to find the value of F, that is 18.3 newtons. And you must mention the units, that is Newton, and for theta it is degree. 5. Part B. Given instead the value of F and the value of theta, find the duration and the exact magnitude of the resultant force. So by using this diagram, we have found two equations, that is F and in terms of theta. Then in these equations, that is this equation and this equation, we need to just substitute the value of F and the value of theta to find the vertical component and the horizontal component of forces. And as we can see that 50 is greater, that means since 50 is greater, so the vertical component is downwards, that is the resultant of the vertical component force is downward, and the resultant on the x component or on the horizontal component is 0. So the resultant force that is only acting is 40 minus 20 root 3, that is the magnitude, and its direction is vertically downwards. So direction is vertically downwards. So the direction and the magnitude, we need to give the exact magnitude, and we must mention the unit, that is the unit is in Newton, and the direction is vertically downwards. Number 6. Two particles P and Q of mass 0.2 kg and 0.1 kg respectively are attached to the ends of a light inextensible string. That means P and Q are attached to a light inextensible string, and the string passes over a fixed smooth pulley at B. Since the pulley at B is smooth, that means here there is no effect of friction. Then particle P lies on a smooth plane AB. So this plane AB is smooth, and this plane AB is smooth, then which is inclined at an angle of 60 degree to the horizontal. So this angle is 60 degree. Particle Q lies on the plane BC and is inclined at an angle of theta to the horizontal. This angle is theta, and the string is taut, and the particle can move on the line of the greatest slope of the two planes. Given the value of theta, that is 60, so we have given the value of theta, that is 60 degree, and the plane BC is rough. So this plane BC is rough. That means since this plane is rough, that means there is an effect of friction, that is mu r, and the plane AB is smooth. So BC is rough. The coefficient of friction between Q and BC is 0.7. So the particle Q and the surface BC, there is a coefficient of friction, that is mu, and the value of mu is 0.7. The particles are released from rest. So these particles are released from rest. Determine whether the particle move. So we need to determine whether the particles move. Determine this, first of all, let's suppose if the particles move, then 0.1 and 2 kg particles move, and 0.2 kg has a larger weight, that means a larger mass, so it would move downwards due to its weight, and particle Q would move upward. And since at this plane there is an effect of friction, that is mu r. Since the object is moving upward, that is upward, so the friction would act downward. And for this weight, that is 0.2 g, 0.2 g where g is the gravitational field strength for this weight and the angle is 60 degree, we need to find its horizontal and the vertical component of forces according to the plane. And for q, we need to find its horizontal and the vertical component of forces. Then, and this tension T is same as this tension T since the string is inextinguishable and the strings are free to move. So these two tensions are equal. And for this particle, that is 0.2 g sin 60 minus t is equal to mass into acceleration, that is the forward force, that is since it is moving downwards, so the forward force minus backward force, that is t, is equal to mass into acceleration. And for particle q, since it is moving upward, so the forward force, that is t, minus backward force, that is its mass, that is its weights this component, and mu r. So t minus this component minus mu r is equal to mass into acceleration. Then we just need to solve this equation, and we have to, since the value of t's are equal, so we can use this, we can equate these two values, that is this value and this value, to find the value of acceleration, whether there is an acceleration or not. If there is an acceleration, that means the particles must move, and so acceleration occurs, hence the particles move. B, it is given that instead BC is smooth. So the plane BC is now smooth. That means there is no effect of friction. The particles are released from rest. At rest, velocity is 0, and in the subsequent motion, the tension in the string is given. So the tension in the string is given. Find the magnitude of acceleration of P as it moves on the plane, and find the value of theta. So the value of tension is root 3 minus 1, and for the particles that move, we must have given that the surface is smooth, that means there is no effect of friction. Then for this moment, we need to find the acceleration of P. First of all, we need to find the value of acceleration, and then we need to find the value of theta. So first of all, what is acceleration? So downward force minus, that is the forward force minus backward force, is equal to mass into acceleration, and forward force is equal minus backward force is equal to mass into acceleration. So for forward force of P, that is this force minus tension, that is this value, is equal to mass into acceleration. And for particle Q, again there is no effect of friction, that is the forward force minus the only backward force, that is 0.1 g sin theta, is equal to mass into acceleration, that is mass into acceleration. Then we solve these two equations and find the value of acceleration as 5 meter per second square. We must mention the units. Then we know the value of acceleration. Then we can substitute the value of acceleration in any of these equations. That is, let's suppose this equation, that is this equation, we substitute the value of acceleration and find the value of theta, that is 13.4 degree. This is our answer. Question number 7. The car of mass 1200 kg is traveling along a straight horizontal road. The power of the car's engine is constant and is equal to 16 kilowatt. So we have given the value of power and we know the mass. So the weight would be mass into gravitational field strength, that is g. So this is the weight and this is the power. There is a constant resistance to motion of magnitude 500 Newton. So this is the constant resistive force of magnitude 500 Newton. Find the acceleration, that is the value of a, of the car at the instant it has a speed of 20 meter per second. So before solving this question, you must remember the formula, that is driving force is equal to power by velocity. So we need to find the value of acceleration. So we know that driving force minus resistive force is equal to mass into acceleration. That is the forward force minus backward force is equal to mass into acceleration. Then we can easily find the value of acceleration. Assuming that the power and the resistive forces remain unchanged, so they are the same, find the steady speed at which the car can travel. We know that at steady speed or at constant speed, driving force is equal to resistive force, and driving force is equal to power by velocity. So we know the value of power, and we actually need to find the steady speed, that is the value of v. So power by velocity is equal to resistive force, and we know the value of power, that is this value, that is earlier given in the question as 16 kilowatt. So we know the value of power and we know the value of resistive force, that is 500 Newton. So driving force is equal to resistive force. After equating, we find a constant velocity of 32 meter per second. 7 part C. The car comes to the bottom of a straight hill of length 316 meter, inclined at an angle to the horizontal of sine inverse of 1 by 60 degree. The power remains constant at 16 kilowatt, so we know the value of power, but the magnitude of resistive force is no longer constant. So the resistive force now varies and changes such that the work done against resistance in ascending the hill is this much. So this is the work done against resistance, or WR, that is the work done against resistance. The time taken to ascend the hill is 15 seconds, that is from the bottom to the top it takes 15 seconds to travel. Given that the car is traveling at a speed of 20 meter per second, so the speed of the car at the bottom is 20 meter per second, and find the speed at the top of the hill. So we need to find the speed, that is V, at the top of the hill. So to find the value of speed at the top of the hill, we can actually use the energy method, that is the work energy method, that is work done by driving force at the bottom plus kinetic energy at the bottom. Since at the bottom we have only kinetic energy and gravitational potential energy is 0 and is equal to the kinetic energy at the top, so we can thus find the velocity, then gravitational potential at the top, and the work done against resistance, and we know the value of work done against resistance, that is this value. So what is the work done by driving force? So we know the equation, that is work done by driving force is equal to, or the force is equal to, that is work done by driving force is equal to power is equal to work done or energy by time, and so work done is equal to power into time, and we know the value of power, and what is the value of time? Time is 15 seconds. So that work done by driving force is equal to power into time. Then kinetic energy at B we know the value of speed, so kinetic energy is equal to half into mass into speed square, where the mass is the mass of the car, that is 1200 kg, is equal to kinetic energy at the top, that is half into mass into speed square, and we need to find this value of V, that is the speed, plus gravitational potential energy, that is mass into gravitational force into height. And what is the value of height? So we know the value of sine inverse of theta, that means we can use this to find the value of theta. Now we know the value of theta, and we know this length, that is the hypotenuse. So we know the theta, we know the hypotenuse, so this side would be sine theta is equal to opposite by hypotenuse. So opposite, that is the height, is equal to 79 by 15. So gravitational potential energy is equal to mass into gravitational force into vertical height, and the work done by resistance, that is already given, work done against resistance. We can then equate this equation to find the value of V, that is root over plus minus this value, and we know that the velocity is positive, that is 21.9 meter per second, and negative 21.9 meter per second is not in our range, or inadmissible, or unexpectable, or not reasonable.